Welcome back to Computer Science 237 Data Structures. This is lecture 9 actually on operator overloading, friends, and references. So these are three things that are somewhat related, but they're all things that are not present in Java. So these are three things, three different things that are not present in Java at all. So the basic idea of operator overloading is pretty simple, but then there's a lot of syntax that we have to learn to be able to accomplish this. The whole idea is, let's say we want to add two objects. Can't we just use the plus operator? Yes, in C++ and in a few other languages you can do that. You can actually overload basic operators like plus, minus, things like array, syntax, notation, even plus plus, minus minus. You can do pre-increment, things like that. So that's going to be the first part of this chapter, and then after that we will look at friend functions. So friend functions are functions that are not actually part of the class. That is, they're not like a method or a member function. They are more like functions that are allowed special permission to access private data members of a class. So we'll also look at automatic type conversion, how to handle automatic type conversion for classes. It's a very useful thing. These are all things that we do not see in Java. Then we'll also look at references. This is a new kind of thing. We've sort of seen it when we looked at pass by reference, but we will see that it's a little bit more general than just a parameter passing. And then the important thing, I think one thing that we have to have done soon is the insertion and extraction operators. We're going to set up friend functions that will implement these operators so that we can, for example, put out an object to cout and have it work. Right now, we haven't done that yet. Okay. So let's start with operator overloading. The whole idea is that we have things like addition, subtraction, remainder, and the Boolean, or the operator that returns a Boolean that checks for equality, things like that. And they're actually really just functions. Even in Java, we actually do use them as functions. It's just that it's not that obvious. It looks like we're just adding two numbers or adding two strings. If you remember, when you add two strings, what you're really doing is just calling the concatenation function of a string. So, but however, in Java we cannot actually overload these operators. In C++ we can. It's just called like a regular function is called, except it's got a different syntax. So if you're adding x and 7, for example, it's like saying plus is the name of the function, and with two operators, that is the first operator is x and the second operator is 7. Okay, so plus is just really a function. It happens to be a binary operator with x and 7 as operands. So we like this notation, that is, we like x plus 7, rather than saying plus x7. That's not so intuitive, mainly just because of the way mathematics has evolved. We like looking at expressions like this. But in fact, what we're really doing is this. It's just that we don't see it this way. Okay, so when you think of it as plus, and then in parentheses the parameters x and 7, you can think of the plus as just like a function name, and x and 7 are passed in as arguments. So, and then all the plus operator or the plus function does, if you want to call it that, they're technically called operators, but let's think of it as a function. Then all it does is return the sum of its two arguments, or its two parameters. Okay, so the built-in operators like plus, minus, assignment operator, equality, remainder, divide, multiply, they already work for C++ built-in types like ints, floats, doubles, things like that. And they work in standard binary notation that we're all used to. And we've used it in Java too. Now here's the thing that's different from Java is that we can overload them to work with our types. We define a class called chair, or we define a class called money, and we can add the plus operator to these classes. So why do we do this? Just because it's nicer to write this, to be able to write this where x is a class, for example. X is an object, an instance of a class. So if you have two objects, x and y, you can now add them if you set up the necessary member functions, or member operators actually. If you set up the necessary member operators, you can write expressions like x plus y, where x and y are objects. So that's the whole reason for doing this. We can overload these basic operators, all these built-in operators like plus and minus. Okay. And the thing about this is that we are comfortable with this notation, of binary operators. And probably, even though you don't have to do this, it's probably a good idea to, if you're going to overload the plus operator, do something similar to addition. You can always overload the plus operator for a class, and instead of adding things, you could subtract things. Sure, you could do that, but it's probably a much better idea to overload with similar actions as the common use of these operators. Okay, so how do you do this? It's very similar to overloading functions, and the name of the function is the operator. So you will see things like this. So you would see a return type, and then here's a keyword that you have in C++ that you do not have in Java. And it's the operator keyword. You say operator, and that's the one thing that's different, and then you give it the name of the operator, in this case the plus sign. And then you, in parentheses, typically this is what's done. You usually set them as const or reference types. Okay, so if you're specifying the plus operator for money, that is, you're taking two money amounts and adding them, this is how you want to do it. You want to say the two arguments should be const money ampersand, so that's a reference to a const type, and these two things. So this would be for a standalone function that would be outside the class. And so typically what we do is we set up member functions, and things will be slightly different. You won't have two arguments, you'll only have one. So this is for, once again, this is for a function that sort of sits outside the class, just a thing that sits separate from the class, but it depends on the class. And what it does is overloads the plus operator for two operands that are both of type money. And as we saw in one of the previous videos, we use these reference, pass by reference types for objects for efficiency. And as we saw before, the alternative would be to not use this, use pass by value, in which case we would end up invoking the copy constructor twice, one for this parameter, and one for this parameter, and that's just not that efficient. You can do it, but it's just not efficient, and so it's much better to do it this way. This is what we will use. We will pass const, pass by reference. And one last thing is where the result of the addition is a money object that you will return inside this function. So the return value is of type money. Okay, so you add two money objects, you create a different money object. Okay, so in the previous example, it's important to note, it's not obvious, but it's important to note that this is not inside a class, this is outside a class, it's a standalone function. So in that previous example, the overloaded plus is not a member function. This definition is just a little bit more involved than a simple add. It requires issues of money type addition, and it must handle negative and positive values internally. You have to figure out what to do with the negative and positive values. Operator overload definitions are usually pretty simple. It's not a huge number of statements inside them. So all you have to do is just perform the addition that makes sense for your type. So I'm going to start out with some examples that are sort of that don't have a whole lot of like meaning, but there's a nice example of a standalone function as we discussed. So this is outside the class, outside the money class, and somewhere where you have to pound include the money.h file, assuming that there is a money.h file that defines the or declares the money class. Somewhere that you can include that, you would define this function. So this is really a standalone function. It's just sort of sitting by itself. It returns a money object, and it's a plus operator that takes two parameters. One is const money object. We call amount1. We call the parameter amount1. The other one is amount2. So take a look at this example. Definitely, it's pretty straightforward. It's a standalone function. And the next thing that I will do is set up a version of this that's used, that's defined in the class. So it'll be not a standalone function, but member function, member sort of operator of a class. Okay, I'll do that next in the next video.